Okay, so I want to see if we can figure out the connection between the different coordinate systems. So I've kept up this picture from the last video, but the real important information is encapsulated in these two triangles. These triangles are going to help me remember the correct formulas, but I do want to keep in mind that these are sort of symbolic triangles. Rho will be positive. For the purposes of integration, we will require that r be positive. Z could be positive or negative. And remember, phi does have some restrictions, but it's restricted to being between 0 and pi. So it's possible for phi to be an obtuse angle, or also 0 or pi over 2 or pi, in which case it wouldn't look quite like that. So I'm going to try to use these triangles to derive some formulas, but I'm going to try to keep in mind the range of values that these things can take on, so that I hopefully get some formulas that are going to be valid in all cases and not just for points that are in the first octant. Okay. All right, so I want to talk first about going between cylindrical and spherical, because they have they have theta in common. So let's say I know r, theta, and z, and I want to express rho, phi, and theta in terms of these. Okay. Well, then my spherical coordinates, I'm going to start with the easy one. Theta is theta. Beautiful. Okay. Now, if I wanted to solve for rho, well, that's kind of nice, because that's just the hypotenuse of this triangle. So I would get r squared plus z squared equals rho squared, but I know that rho is positive. Fabulous. Rho is the square root of r squared plus z squared. That's a unique formula for rho that's going to work every single time. Okay, doesn't matter whether z is positive or negative. I just have a triangle that was below the xy plane instead of above it. Okay, excellent. Now, if I take a look at phi, okay, I can see that I could use some trig functions here. I could say that tangent of phi is r over z. And it's very tempting to use that. That's true, and that will always be true, that tangent of phi is r over z. That does give me a nice relationship between things. But that's not sufficient for me to be able to solve for phi, because I can't take inverse tangent, because the range of inverse tangent is from negative pi over 2 to positive pi over 2. I want phi to be between 0 and pi. So I'd rather use cosine. If I can use cosine, the range of inverse cosine is exactly the same as the range of phi. So if I look, cosine would be z over rho. Now it seems like that doesn't really help me so much, because I was trying to express phi in terms of just my cylindrical coordinates, but I can express rho as root r squared plus z squared. So cosine of phi is z over root r squared plus z squared. And because the range of phi and the range of arc cosine are the same, I can then say that phi is equal to arc cosine of z over root r squared plus z squared. And that will work every time, even if phi is negative, because that is in the appropriate range. Okay. So that gives me a way of expressing my spherical coordinates in terms of my cylindrical coordinates. I don't recommend that you necessarily just memorize all of these. What I do recommend is that you practice deriving them on a fairly regular basis. Okay. Now, there will be some formulas I'm going to encourage you to accidentally memorize. These we're not going to use quite as often as some of the others. Okay. All right, let's try going the other way. So here, I suppose that I knew r, theta, and z, and I wanted to figure out what my spherical coordinates, rho, theta, and phi, were. So now, let's change that. Let's suppose that I know rho, and I want to get my cylindrical coordinates. Okay, well, theta is theta. That was fairly simple. Okay, so now I want to try to get r and z here. Okay, if I look at this triangle, rho is the hypotenuse, r is the opposite side. So I could say sine of phi is equal to r over rho, which would imply that r is equal to rho sine phi. That will work every time as long as we restrict r to being non-negative, which we're going to do if we're integrating anyway. Because rho is never negative, and if phi is between 0 and pi, then sine of phi is never negative. So I got that from this picture where phi was an acute angle. You can verify fairly easily if you had the scenario that phi was an obtuse angle, we get the same formula. Okay. Now, similar thing here, if I want to get z, I can see that z is the adjacent side. So I could say that cosine of phi is equal to z over rho, and that would imply that z is equal to rho times cosine of phi. Now that definitely works if I have a picture like this, which would be if my point is in the first octant. If phi is obtuse, and basically if z is positive, because I could have a similar picture in any of the octants above the xy plane. If z is negative, phi would be obtuse, because we would have to be below the xy plane, so we would have had to rotate past pi over 2. So we would have an obtuse value. Well, cosine of an obtuse angle is negative, so I get negative z values when that's the case. So I do get these formulas that do work in all cases, but I'm able to figure them out by sort of referring to this triangle that I got from the nice case corresponding to a picture that's in quadrant 1. Okay. All right, so let's now see if we can go back and forth between rectangular and spherical coordinates. Okay. So I'm going to suppose, again, that I know my rho, my theta, and my phi, and I want to get my rectangular coordinates. So I want to get x, y, and z. Okay. I'm not going to go straight from spherical to rectangular, because I don't have a triangle for that. I'm going to take a detour. I'm going to go from between rectangular and cylindrical and then spherical. Okay. So if I want to describe x, I know that x is just r cosine theta. And I can always remind myself of that by looking at this particular triangle. Cosine of theta would be x over r. Solving for x, I get this. But now I know what r is in spherical coordinates. Remember we had that sine of phi was r over rho, so r was just rho sine phi, and then times cosine of theta. Now, x being rho sine phi cosine theta is a formula I'm going to suggest that you accidentally memorize by deriving it multiple times, once a day for a while until you know it. We're going to be using it a lot. It's kind of nice to have it. Okay, but don't just create flashcards. Work through these triangles to get there. Now, if I want to describe y, I would first go to cylindrical coordinates, and I would say, oh, that's r sine theta, okay, which again I get from this triangle. And then from this triangle, I get that r is rho sine phi. So y is rho sine phi cosine theta. And then z is nice, because z is also a cylindrical coordinate, so we had determined that z was just rho cosine of phi. these three formulas we will be working with an awful lot. Okay. What they will allow us to do, here it looked like we went from knowing these to these, but I'm expressing my rectangular coordinates in terms of spherical coordinates. That's what I'm going to need to do if I have an integral and I want to switch to spherical coordinates. So I want to switch to describing x, y, and z these ways. Okay. All right, last thing to take a look at is what if I knew x, y, and z and I wanted to express my spherical coordinates in terms of that. Okay. Well, the theta in spherical coordinates is exactly the same as the theta in cylindrical coordinates, so I would just use that triangle to get the tangent of theta is equal to y over x. Again, I cannot simply take inverse tangent because that would only give me angles between negative pi over 2 and positive pi over 2, so I would have to use the quadrant that the point xy is in to pick a theta. So it would have to be an angle such that that is true and that landed in the appropriate quadrant. Okay. All right, rho, well, that's just the distance from the origin. I know the distance formula, so that's just the square root of x squared plus y squared plus z squared. That's fairly nice. Okay. And if we look at phi, what we had said previously was that cosine of phi was z over rho. And since the range of phi and the range of arc cosine is the same, we could use arc cosine. So this is just going to be arc cosine of z over rho, but rho is root x squared plus y squared plus z squared. Lots of formulas. I'm more concerned that you understand the geometry of things and can figure things out, but I will tell you the three that we'll be using most often are that x is rho sine phi cosine theta, y is rho sine phi sine theta, and z is rho cosine phi. So if you can work on getting yourself familiar with those, you'll be in good shape as we move forward.